So this last part of the lesson is about using systems. So we already started with a system of two equations where we have two equations with both y and x in them. Now we're going to say, well, how can we use that graphing idea that we just did on the last page to solve equations with only one variable? So that's what it says here, just kind of said it in my own words. Basically, when you're doing this, solving a one variable equation graphically is like doing guess and check everywhere at once. So a graph is basically when you draw a graph of a function, you're plugging in every possible value into that function and seeing what its output is. So the connected line shows all those different values. So the two graphs we're going to make show the values of each side of the equation for every x value at the same time. And we're going to look to see what values of x make the functions equal or where they intersect. Because you are using the graph as a tool, you do not have to draw it here. So that's a biggie. Basically, we're just going to write down what we do. You don't have to draw the graph. You do need to write the equations you graphed, the intersection points, and your final answers, which is just the x values. The original equation did not contain y, so the y value is not part of your answer. So part of, as you move into math, you really have to stay aware of what you're finding. So when I see this equation, that's not something we've solved in here, right? We're solving the following equation, and we're going to solve it graphically. My original equation only has x's in it, so my answers are just going to be x values, okay? But because this is an equation that I don't know how to solve algebraically, or maybe I just feel like solving it graphically, we are going to bring in the variable y so we could graph it. So what we're going to do is we're going to graph the first side as y1, and the second side is y2 on our calculator. So whether you're working from a graphing calculator or Desmos, remember the keyboard on Desmos has an absolute value sign. If you are on the graphing calculator, it's alpha, window, sorry. I'm close to this like spot where I can pick the pens and I just got too close and picked something out. Window number 1, that's how you get absolute value. My second equation I'm going to graph is absolute value of 0.5x minus 5. So I've introduced the y variable into this equation. Basically, I'm going to look at the graph. Your x window has to be big enough, so you might have to zoom out or change your window so that you can see or you're in the range of those intersections. Then what I'm going to write down is that I found the intersections. So sometimes you can see intersections in the table, but if they involve decimal values, you can't. But you could look in your table for the intersections, but you want to use that second calc intersect. I'm going to make a separate video that's on a computer of exactly how to do that. So if you need to watch that video, you can. But the basic is you're going to find those intersections, and those two graphs intersect at -4, -3, and 8, +1. So that means the solutions to my original equation that only contains x's are x equals -4 and +8, or we could write those two answers because they're both x values in roster notation. So the process for each of these is the same. Like on my next one, I would graph the first side of my equation as y1, the second side of my equation as y2, and from there I would find my intersections. So I'm just going to write intersection. As I said, go watch that other video. It's linked in the calendar for using the graphing calculator for that piece if you need to. Now this one only has one intersection point. If I look at those two graphs, basically one of them's exponential and one of them's linear. So just sketching on the side so you guys can see what those two graphs look like. Basically we have the 2 to the x looks like this, and the -3x + 8 looks like this. So there's only one intersection, whereas on the last one we had two spots where they crossed. So that intersection point, if I do my second calc intersect, to the nearest 10th we said here, so this is a rounded answer, is 1.63.1. So that means the answer, if I solve this equation to the nearest 10th, is x equals 1.6. If I was going to put it in the roster notation, I would just put 1.6. So moving down to the bottom of the page, exercise 4 is actually something that we already did algebraically back in lesson 16. So it says the equations in exercise 3, what we just did, are not something you know how to solve algebraically, but you can solve them graphically. The following equation was in lesson 16. We're going to use a graph to solve, and then go back to page 19 to check your solutions. You may have to adjust your window to see the intersection points. So because I'm solving this graphically, we know we're going to graph the first side like this, and the second side like this. So through all of this, hopefully you have a calculator, you can go and look at those graphs. So initially I just typed them in my calculator. Basically when I graph them, the one graph goes kind of like this, okay? And the other graph comes like this. And this is all I see. Now, if I think logically about it, right up here somewhere, they're also going to intersect if we were going to continue that. So I'm going to press the window button on my calculator. I want to see higher in the y direction. So I'm going to make my y max 20. So they have a menu. That's not high enough. So I'm going to go back to my window and make my y max 30. I'm also going to go down to negative 20 for y min. So as you should see, negative 10, 10, negative 20, 30 for the y min and y max. Sorry, I'll say that again. The x min, x max should be negative 10 and 10. The x scale will stay at 1, x SCL that says. The y min is negative 20 and the y max is 30. So when I graph it, instead of seeing what I have here, so I'm going to erase that. Now my graph looks like this. Okay, this is a super rough sketch, but that's the basic idea. So now I can see, well, there's two spots it intersects, and I need to find both of those. So if I did my second calc intersect, and that graph is optional, I'm just kind of showing you guys how if you move the window around, you can see the intersections. My two intersection points are 3, 4, so that's the one right here. And then negative 8, 26, right? That's why this one was way up here above, you know, y equals 10. So for this problem, remember my original equation only contains x values, so my answers are negative 8 and 3. And if I, in my packet, and I don't have that slide here on my video right now, but I'm going to flip in my packet back to page 19, okay? If I look for this problem, I see that it's exercise 2, letter C, okay, on page 19, okay? And yes, I did solving algebraically. I got the answers 3 and negative 8. That was a pretty easy one to do algebraically, so I'd probably still do it algebraically, but a quick graph, right, without any work, just kind of looking at it, you know, can see that, oh yeah, it makes sense that 3 and negative 8 would be my answers.